The metric units of length are millimetre, centimetre, metre and kilometre. You have to know that there are 10 millimetres in 1 centimetre, that there are 100 centimetres in 1 metre, and that there are 1,000 metres in a kilometre. You need to know those measurements when you're working with length or with perimeter. If you've got a shape, then the perimeter is the distance around the outside of that two-dimensional shape. For example, if this was 3 metres, this side 4 metres, 5 metres and 6 metres, to find the perimeter, P, I just start at one spot and I go round the outside and add the numbers. So 4 plus up there 5, down that side plus 6, and then back to the start again plus 3. And if I add those numbers together, I get 18, but there is a unit there, so the perimeter is 18 metres. We can also bring in algebra into perimeter, because if I have a shape like this, an isosceles triangle, if this side is 5x and this side is 3x plus 2, and I ask you what the perimeter is. Once again, it's the distance around the outside. If I start at this point, I have to add that side with that side and that side. So starting there, going up the side, that one is 5x. Coming down the other side, there's no measurement, but because of those lines, we know that it is also 5x. Then across the bottom, back to the start, and I have to add on 3x plus 2. Remembering you can only add like terms, so 5x plus 3x is 13x. The plus 2 hasn't got an x, so it's can't be added to the others, so it's just tagged onto the end. So the perimeter of that shape is 13x plus 2. Going back to our units of measurement, say for example I wanted to, if I had 5 metres and I wanted to find out how many centimetres that was. I have to look at my conversions and think, okay, how many centimetres are in a metre? Okay, we look above and we know there's 100. Because we're going from a big unit like a metre to a small unit like a centimetre, there's going to be more of these. So we have to times it by 100. So if we times 5 metres by 100, or 5 by 100, we end up with 500 centimetres. But if I want to change 5 millimetres and figure out how many centimetres that is, I look at my two units, millimetres and centimetres. How many millimetres are in a centimetre? 10. But because we're going from a small unit to a big unit, there's going to be less of them, so we divide by 10 instead of multiplying. And then 5 divided by 10 is 0.5 or a half. So 5 millimetres is 0.5 of a centimetre. With area, area is the space that a 2D shape takes up, and it is measured in square units. Now remembering that 10 millimetres equals 1 centimetre, if I went along and squared each one of those, 10 squared is 100, then we have millimetres squared, 1 squared is 1 centimetre squared. So that's the conversion from centimetres squared to millimetres squared. So if that square that I've just drawn is 1 centimetre squared, that means that's 1 centimetre by 1 centimetre. If I divided it up into millimetres, there would be 10 little gaps down there. 1, 2, 3, 4, 5, 6. Okay, 10 down that way, and then if I went 10 this way, that means there would be 100 of those squares that would make up that 1 centimetre square. The same idea goes for the conversion between centimetres squared and metres squared. We know that there are 100 centimetres in a metre. If I go along and square everything, 100 squared is 10,000 centimetres squared equals 1 metre squared. So there are 10,000 centimetres squared in 1 metre squared. The last measurement, if there are 1,000 metres in a kilometre, if I go through and square each of those, I end up with a 1 and 6 zeros. So 1,000,000 metres squared in 1 kilometre squared. There is also a measurement called a hectare, and a hectare is a square measurement. It's abbreviated by HA, and a hectare is 100 metres by 100 metres, about the size of 2 footy fields side by side. Finding the area of different shapes. If you've got a square, then all the sides are the same length. Let's call them S. And the area of a square is S times S, or if you like, S squared. Rectangle, depending on what you call them, I'm going to call it length, L for length and W for width. Then the area equals length times width. A parallelogram is a rectangle that's been pushed over. It's similar to the area of a rectangle, except we have to be mindful that we look at its height. Height is this way, perpendicular to the base. This is the base and this is the height. It's perpendicular height. So the area of a parallelogram is base times the height. And lastly, the triangle. For the triangle, we also need the height, and that height has to be perpendicular to the base. So this is the base, and this is the height. But the area of a triangle is half the base times the height. Because if we were to fill in the rectangle, then this triangle is half, or is the same size as that one, and this triangle is the same size as that one. So it's actually half of the rectangle that contains it. Now, the other thing we have to be mindful of is sometimes triangles look like this. The area is still half the base times the height. If this is the base, the height has to be perpendicular, so that would be the height. So you have to be careful that the height is perpendicular to the base.